Hello and welcome to Java Collections. In this video we'll talk about an array list, which is primarily the most important collection type we have, or the most used collection type that we use in collections. This video is in continuation with our previous discussion of the vector examples. Vector is actually the primitive examples, the very first collection which was introduced. ArrayList is, on the other hand, is a very newer one and a very latest one we have in the collection, and it is highly used. So when we talk about collection, the first thought that comes to your mind is an array list. Let's take an array list, put a collection item into it, and then start operating on top of it. Why we use array list is, first, the basic difference between vector and array list is all the array list methods are not synchronized, so they don't give you any performance hits. They are a little bit faster. They can be used in multi-threaded environment where they can be shared among multiple threads. Okay, so we'll discuss about ArrayList one by one. The most important thing about ArrayList is it's a resizable array. Just like vector, this is resizable. This can grow as per requirement. It will start with the basic size, and then as per requirements, as per the need of the program, need of the application, it will grow its size. It implement all the optional list operation and will permit you can include a null element in my ArrayList also. In addition to implementing list interface, it can provide method which can manipulate the size of the array which is used internally to store the list. See, this class is roughly said to be equivalent to vector, except that all its methods are unsynchronized. Okay, moving forward. Okay, so we'll take about ArrayList again one by one. ArrayList is a class. It's a concrete class which implements a list interface. It is very widely used, most commonly used across the collections because of its functionality and its flexibility which it offers. Most of the developers, they choose ArrayList over array because it's a very good alternative for the traditional Java arrays. It can grow in size. There's no need to hard code the size of it. It can grow, it can shrink as per requirements. Again, ArrayList is a resizable implementation of list interface. The issue with array is that the issues with array, as we talk about comparison of array and collection, is arrays are a fixed size. They take only homogeneous elements, and they can take only a single type of elements. On the other hand, ArrayList as dynamical, we can grow. It's a resizable implementations. Second is you can use ArrayList is built on top of some pre-built data structures, so we will get some ready to use methods which is not available in my arrays. Like, it will give you a lot of method which we can use in our day-to-day applications. Moving forward, some of the basic ArrayList operations which is supported by the underlying data structures. First is we can add an element to an array. We can add an element by passing the index location of it. We can remove an element, remove a particular index location. We can set an element at a given index. We can take the index of an element. We can retrieve the element by passing it the index number. We can see the size of my collections. We can clear out the collections, make it empty. Okay, so to start with the implementations, we can start with any Eclipse, any IDE of your choice. I prefer IntelliJ. So here we'll start writing some code, and we'll say my ArrayList demo. We'll start with a quick main method here. Just to say this, here we define a list interface. We take it of string type, say it my ArrayList, and we'll give it as ArrayList as the concrete implementation class. We can import it. I don't know why it doesn't work for me. Okay, so this has been imported. After this, we can add some element to it. We can add some test string, test1, test2, and test3. So after this, we'll start with one by one some of the methods that we have with our ArrayList. First, start with to retrieve an element by passing the index number. So what we can do is we can just print out the element at index 1 is. We can take it as a my ArrayList and we'll pass the index number here 1. See, we can just see the implementation. We can get an element by passing the int of index number. So we can pass the index number 1, it will retrieve the element and return me the element we have at my first index. Second, we'll start with to check whether my collection has an element or not. So what we can do is we just print it, does ArrayList contain say make it test1. What we do is we can say my ArrayList, we have a method contains, so contains will check for a particular object, so we'll pass it test1. We just see whether we have this method or not. Next is we can quickly see my ArrayList. When we click and add an element, first we get it, we can add a string to it. Second is we can add a string by passing the index number. Say I want to pass an element at the first index, and it is a new element at index 1. What we can do is we can quickly run it. We can right click, run it, and see what we have got so far. Okay, so what we can see is my element at index 1 is the test2. So the element we have is at 0 index we have test1, at first index we have test2. Okay, just to make it more clear, we can just simply print this, print an ArrayList. We can right click and rerun it. See, my ArrayList has 3 elements, a 0th index, first and second index. So at the first method, element at index 1 is my test2. We can by passing the 1, we are taking the element test2. Second, we can just checking whether we have this element or not. Does ArrayList contain test1? So it is true. Yes, it added. After this, we have added a new element at 1 index. Now at first index we have test2. Now we have replaced with a new element. Okay, so we'll just print it and we'll see what is the updated ArrayList. Just give it a placeholder. We can right click and run this just to see what we have got. Okay, so at first index we have added a new element at index 1. Okay, fair enough. Okay, so moving forward, we can start with the new element is empty, just to check whether my collection is empty or not. We'll just print this out. Does my ArrayList is empty or not? What we can do here is we have my ArrayList dot is empty. See, is empty is boolean. It will return me yes or no, whether my collection has empty or not, or it has an element or not. Okay, next is we can retrieve an index of an element, index of a particular element. We can pass an object and we can see what is the index of, let's say index of my test2. What we can get is my ArrayList. We can take the index of will take an object, so we'll pass the object test2 here. It will retrieve me the exact index number. We can right click and quickly see what is the output here. See, my index of test2 is second index now. This is the first index, this is the 0th index, this is the first index, and this is the second index of my test2. Okay, fair enough. Moving forward, we have got a size of an element, size of the collection, sorry. So it will tell me what size does I have with my collections. What's the size of the collection? We can have my ArrayList and we'll click the size of it. It will return me how many elements I have in my collection. See, now I have 4 elements in my collection. Next is we can see the iterator method. As we have already discussed, we can quickly discuss the iterator here. My ArrayList dot iterator. This iterator will return me an iterator class instance which is of string type. Iterator implementation is left to an ArrayList. For this I need a placeholder we can keep an iterator, keep it generic to string, and make it my ArrayList iterator here. What it will give me is, we can access every element of my collection from this my ArrayList iterator instance. How I can do here is, it's an old style of writing it, my ArrayList iterator has next. This will return me if this is a while loop. This will keep running until I have more elements in my collections. We'll see has next, and after this we'll just print the element of the collections are. What we can do here is, we can take the my ArrayList list iterator dot next. This next will give me the exact next element I have in the collections. So I can iterate through every element and we'll see what all elements I have. We can quickly run and see the output. So see, element of my collection are test1, new element, test2 and test3. We can iterate through every element of my collections. Next I have is like how I can make a clone of an existing collection. We have a myArrayList.clone here. Okay, so next is add all elements. Add all elements, we have to make a new list, define it another string type. This is a test list. We add it into a new ArrayList. We add some element to it. We can add string object here. Let's say ABC, and just make a copy of it. Now what we can do is, we have ArrayList and we can add all. See, add all will take every collection which is extending string. So we can add all and we can add a test string here. So it's like my one collection is now holding another collection into it. Next is, we can check whether does it has this collection or not. Does collection has the other collection or not. What we can do here is, we can have my ArrayList if say contains all of collections, and this collection would be of test list. Just to test, we can quickly right click and run. Yes, my does collection has the other collection or not. Please avoid the spelling mistakes. Okay, the next is a to array. Okay, so here is next is my to array. So what we do is, we have a my ArrayList and here we have a to array. We'll convert it into, we'll move a complete list to another new array elements. So for to array, I have to pass an object in it. See, this is expecting an argument of string array. So what we do is, we create a string array to copy, and we make it new string and give it my ArrayList and the size of it. See, this is how we used a method of a collections, and the size would be specific to my ArrayList here. Now I have an array which is blank array which can be copied. So what I do is, we have my ArrayList and then we use to array. We convert this array and pass the array to copy. Now this array is holding all the elements of my collection. Just to check, what we can do is, we can go through every element of it, string str, and we say the array to copy, and we just print every elements within the array. We just print str here. We right click and run this program and see where we are. Okay, so elements within the array is all the new elements that we have within the collections. Second is, this is how we can do as a older version of it. Now what we can also do is, we have an array to copy, and does it has for each? No, array does not have. Last but the final method that we can use it is my sublist. Let's say we have an array list of few elements around 1, 2, 3, 4, 5, 6. We can take a subcopy of it. Sublist is like a subsection of a bigger collections. So what we do is, we print sublist of the array list is. What we can do here is, we have a my array list dot sublist. We give the starting index to the last index. and this would be a smaller version of my bigger collection. We'll right click and see. Okay, so my sublist has only 3 content, starting from 2nd, 3rd and 4th. That's pretty much all that we have. Some of the most common methods which we can use. Now coming back to the presentation. So here we can again revise all the elements. What we have done is we have taken an array list, put some element into it, let's say 4 elements, and we see the actual array list. After this, I can retrieve an element by passing the index number, as we do for get 2 here. Next is we can see whether we can cross check, and we can see whether my element has this element or not, whether my collection has this element or not. So we'll see my contains Java contains a particular object or not. Second, we can add an element, even specify the index number where I want to add it. Moving forward, what we can see is whether my array list is empty or not. I can cross check whether my array list still has some content or not. After this, we can, to retrieve an element, my list maintains the insertion order. It maintains the exact position where my element is, which is by the location of my index. So my array list keep a track of my index number of all the objects within my collections. So I can retrieve the index of by passing it the particular object. Index of will give me the index of actual object, which is the part of my collections. Next is we can print the size of an array list. We can see what is the total number of elements that we have within a collections. Moving forward, we have seen the iterator. We can call an iterator. By this iterator reference, we can see whether it has the next element. Until it has next element, we can go one by one and print the next element. We can perform the business logic or some permutation combination on top of this next element as well. Moving forward, we can make a clone copy of an array list. It should work. I'll just cross check and come back on this. Next is we can take a list of an element. We can take a new smaller list and we can add to a bigger list, like add all, and add all will take a collection which is a pre-existing or preset of a collection and add it. Moving forward, we can check the complete collections, whether this bigger collection has some other small collections or not. Moving forward, we can see the collections. We can convert it into an array. We can take a string array and copy all the elements to array in the new array we have. Then we can iterate through every element and just print them. Last is the sublist of it. We can pass the starting index and the ending index, and we take a smaller version of my collections. Next is a small business logic, which we will discuss later, definitely. This is nothing but we are converting a normal array list to a comma separated values. So what we do here is, it's a very simple implementation. We take a string builder because we have to do a business logic or some changes on my existing object. We take a string, we'll take an every element, and if my element is not equal to 0, so we'll start with this. Since the element length is not 0, we'll start appending a comma separator to it, to the every elements, and then we append the new element over here. So by the time we are done with this, we have converted a normal collection element to a comma separated CSV value elements. Nothing fancy, nothing big about it.